Hello guys, in today's video we'll show you how to create airdrop with lots of NFTs. It's called MerkleDrop and you can check it out on openzeppelin contracts if you want in a repository. We'll leave links in descriptions if you want to check it out.
Yeah, we are working based on the openzeppelin workshop. So if you want, you can check off the original contracts, and basically everything will be the same or almost the same on our side, but there will be differences regarding JavaScript code for web interface we'll use for creating the airdrop. So previously we recorded a video about creating airdrops, but not using Merkle trees. We used lazy mean solution so that the creator of the NFTs wouldn't pay for them. He would only pay for the smart contract deployment, but the people who receive NFTs would pay for the minting. And this time we'll do the same. The difference is we won't be using a simple 712 signature checker or just a 712 version, but we'll use Merkle tree so that the NFT list will be more optimal for huge airdrops, and also it will be immutable, so it has pros and cons. When it's immutable, you can't, like, once you create the list of receivers and what tokens they receive, you can't change it. And so if you want to be able to change it later on, make sure to see our previous video. This time it will be immutable. And also another pro is that it looks more legitimate for some users because it creates more scarcity when they are sure that you won't be able to mint more tokens on top of the existing ones, and that you won't inflate the collection. So yeah, let's go back to the original token and we can go through this one.
Okay, so here we are. Here's our main contract, MerkleDrop. The main function we want to focus on is the function redeem, where we verify through leaf, where leaf is hashed data, in other words, token information. Also, we'll use the proof for that. And for the verify, it differs from normal verifier. If you saw in our previous video, there was no root before, and here we have immutable root, which checks if the leaf belongs to the root. You can see all the information in this constructor where the root equals Merkle root. Here's our immutable data. And also we have to set our URI. It's the second most important function here. So to do that we have to go to Pinata. Let's go there. And as the normal process in Pinata, we also mentioned something about that in our previous video. We go for the upload. Let's do the folder. We'll select the folder with our metadata, great. Uploading, and we'll set the name. Okay, fine. Well, now we have to wait for our metadata to appear. It might take a while.
Yeah, but in the meantime, I can mention that when you create a folder, it's immutable, so we won't be able to add more files into it. But we'll probably record videos about how to make a mutable folder later on, so if you want to keep track of new stuff, just subscribe. It's very slow, so maybe you could use an existing collection.
Yeah, that's that.
And we just need to make sure that the files inside are alright. Yeah, so this is an example of a run collection because we have the .json thing, and if you want to use base URI, then we just want to set some names like this without the extension in the file name. And here it's done properly.
So let's use that one.
Yep. So which one was that? It was
It
probably
was the first, I suppose.
metadata. Yeah, just double checking. And I think that we already have it pasted here, so we can just leave that and make sure that we have the slash at the end, otherwise it won't work.
Okay, if it's our IPFS, so now we can deploy the contract to use it for our next script. So let's inject web3, yeah. We have to set the name, the symbol.
Oh, it's not the right one.
Not MerkleDrop, okay. And our immutable data for the bytes.
Yeah, so it's done, but now we need the Merkle root. So to do that, we need to move to our Web3, to our JavaScript. Now, as the last blocking thing from deploying our smart contract is the Merkle root, we need to move to our HTML/JS script, and here we can go through all of it. So starting with the dependencies, we'll be using jQuery for buttons, click listening and error messages. We'll be using Web3, Morris and Eaters here for blockchain communication. And my last thing is Merkle tree and Kesak for the MerkleDrop. And the Merkle tree JS library is not random here, because if you go to openzeppelin contracts and you open MerkleProof, it recommends you to use the set library, and it says that we need to be using Kesak 256 as the hashing algorithm, and that we need to enable pair sorting. And the MerkleProof is something used in the contract we use, as you can see here, for the verification. So now going back to our file, here we declare a few buttons for generating the whole tree, for loading information from our MetaMask account, for checking whether all of the things we minted actually exist in our wallet, and hex root button for generating the hex root that we'll use to deploy our smart contract. So then we are here, and we start with providing a list of recipients and what they get. So here, for example, this account will get token ID number 1, and next account it could be a different address, but we are providing 2 NFTs for one account, gets the NFT of number 2, and we use 1 to it will go up to infinite, unsigned infinite, because all of the NFTs that are minted in our smart contract, we also have the auto-generated ID, so it go like 1, 2, 3, 4, 5. So you can add more of them, and usually if you do the MerkleDrop and not other ways of doing airdrops, then you probably have a lot of tokens, so it would make sense to export it to a separate file if you have like hundreds of them. But for simplicity, we just keep everything in the JS file. And what's interesting here is that we are not using a lot of stuff that's dependent on React, on Node.js, and other frameworks. so to make it simple and make it easy to integrate into any project, we only use the scripts provided here. So now we can create a new object of Merkle tree. We provide the list of tokens and we map it. So for each token we hash it, and we say that we want to use Ketzak for this and we want to sort pairs. Then we provide connection address and we paste the address of the deployed contract, but we don't have it yet, so we can just paste it later. And then we add MetaMask integration. So both the new way of integrating with MetaMask and the legacy way that's still used by some clients. So we support both of them. If there's a problem, we say that somebody needs to install MetaMask or something similar. And all of the heavy paths default to the init app function, which inits all of the things we'll be using. So headers, Morales. Here you'll need server URL and app ID that you can get when you register on Morales and you create a new server. For this case, it should be a Rinky testnet server. And then we have the generate tree button, and it will create the MerkleDrop and store all of the information in a new file so that we have all of the info and we don't lose it. So the main function makes sure that everything's alright with MetaMask, and then iteratively goes through the list of our tokens. So again, the list of who gets what. Then it's for each token, it gets proof for it using token ID and address, and fills the token objects empty array with all of the information that we can store into our Merkle tree. And how the getProof function works is down below here. We use the Merkle tree object created before to get the hex proof of the hash token, and we return the object with all the information we need, so token ID, address, and hex proof. And once again, it will be saved into our Merkle tree file. Down here we have our load button, which we'll be using for getting the information from Morales, and this case is very simple. Here we use the account directory and the get NFTs endpoint with on the Rinky chain, and we provide address of a user we want to check on. So we'll be checking whether the given address has all of the NFTs we just minted. And here we have a separate function. I think that we're not using it here yet, but just to show you how the thing works in general, you need to be aware of the directories. So if you want to get a single token ID metadata, so all of the information regarding name, description, attributes, image, you need to change the directory and only then the endpoint, the last part of the endpoint. Here we have the init hex root button, and it's very simple. It just takes the Merkle tree object and then it returns the hex root, and we'll need the hex root for deploying the smart contract. Now hash token function, which differs a bit from from what's in other tutorials, because in this one we are not using Node.js, and Node.js provides a cool buffer class that's a bit simpler than the hex string to uint8 array. And you can see that in it's not here, it will be in the workshop files. When you go to the MerkleDrop test, you can see that they use the buffer from function, which is a bit shorter, and I would default to it if you use Node. So yep, ideally you don't even use this one, and you're left with this simple line of code. So what's next? We are only left with download file function, and it's just a simple function from Stack Overflow for downloading the JSON and saving it on your disk so that you have all of the information. Of course, you could print everything to console, but then you can lose it, and I think it's better to store it in a separate file. So yeah, all of the source code will be uploaded to our GitHub repository, so you'll be able to check that. And now, as we went through all of the code, we can run it. To run this in a browser, you will need to use a web server, because if you try to work with MetaMask without a server by just dropping the HTML into your browser, it won't work, so we need a server. And we'll be using Live Server plugin from Visual Studio Code. And we use the open with Live Server thing. And then we are on our beautiful site, in which we can start with generating the tree. So we click on the Generate Tree button, and it processed everything and created the file with all of the information. So we just store it on the disk. And then we can open it here. Another plugin you could use is Format JSON to have a better experience here. And as you can see, you have all of the information about the MerkleDrop, and we'll be able to use this for the redeem function in our smart contract. But before we deploy the smart contract, last thing we need is the hex root. So we click on the button, and we have the ultimate hash of all of the node pairs here. So we can copy it, and now we are ready to move to our smart contract. And then when we provide it with the hex root here, we'll be able to mint, the users will be able to mint the NFTs they should get specified before. Yep, so it's confirmed, and now we can switch to other user, and I'll select this account, and we have all the information you see here in the interface in our MerkleDrop file, Merkle tree file. So we can just copy it and it's account, so token ID here, address, and hexproof, which we'll need to copy and paste it here. But we need to make sure that we use the proper syntax, so we are adding the square brackets and comma, and then a square bracket again. And now we are ready to mint. The only mistake I made is it's prepared for account 0x320, so ideally we should switch to the account that wants to get the NFT and mint it using it here. So now everything's alright, so we can mint the token, and after that we can make sure that everything's secure by trying to mint, for example, token ID 3 or yeah, so it's invalid Merkle proof error because the leaf that was created here doesn't match the root hash we provided while deploying the smart contract. But we'll be able to mint this one because it exists, it's provided in our list, and for that we also need another proof. So it's this one for number 2 with the square brackets. And we can create it too. I think that's when we provide a different account, we'll get an error too. So if it's, even though the token ID of 3 exists and we provide the right proof, so it's this one, if the recipient is incorrect, the hash will differ too. So the transaction shouldn't go through. And now is the time where Remix fails, and hopefully it starts working back. But I'm not sure on that, so shortly we'll show you how the collection looks more visually.
Okay, so let's go back for the Opensea.
Okay.
Okay, so we need to go for the assets. We can get our contract address after that.
I'm not sure we can.
Oh, yeah, Remix.
We took a break and Remix still not responding, and so I probably have to clear the storage and get back here later. But and now we can check whether the tokens were actually minted and if minted correctly. So I'll just close Remix as we won't recover it, I think. And to get the token address, we can go to ring-b Etherscan and copy our address we used for deployment and search for recent transactions. As you can see, here is the token creation, so you can check the details of this transaction. And this address, this contract was created. So yeah, it's Merk, we can copy the address and use it in our script now. So it's MerkleDrop, and we had the collection address somewhere. Oh yeah, it's here. So now we can paste it because we have it now, and we can use our I'll refresh to make sure it's the right one, and we can use our load button to get the information from Morales about of the tokens. So you can see that it's number, no, it's amount 1, but it's the right symbol. We have the token ID, and we have the year we provided. And well, actually not Fury provided, but wrapped by Morales IPFS gateway, but with our SID. And we have the right owner and our metadata. So yeah, we checked it here, but it's better to make sure that it's alright visually, so we can check it on Opensea too now.
Yes, and to check it on Opensea, we have to go for the testnet Opensea, because we used RinkyB, and we will go to the assets, then we will copy paste our contract address, and we'll use the token ID we want to check. And here it is, the Thunder Dragon. If you checked it in the previous thing that Jacob mentioned, in the script you could see metadata for the Thunder Dragon, so it matches. It's the same one. For the IPFS we have to wait, because it's the image decentralized, but here you can see that it will be looking like that.
Yeah, it's the second one and already loaded. This image that processed faster. And if you click on free, it doesn't exist, we limited only 2 tokens.
Yes, that's right. And now you can see that clearly. Okay, so I think it will be everything for today's video. Next time we plan to create a video about upgradable contracts, so keep in touch, leave sub if you want, and see you next time. Hope you enjoy our content.
Yeah, we'll have a lot of videos about new things, so let's stay in touch, and thanks, see you.